You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine waking up tomorrow, grabbing your morning coffee, checking your company's repository, and discovering that 80% of the new production-ready code that shipped overnight wasn't even written by your engineering team.
Right, yeah.
It was written by an artificial intelligence, just, working the night shift. And that is not a pitch for some sci-fi movie. That is a direct benchmark reported by Anthropic in the first week of June 2026.
It's honestly wild to think about.
It really is. Welcome to this deep dive. Today, we are looking at a massive stack of intelligence pulling from Anthropic, OpenAI, Meta, NVIDIA, and a bunch of open source releases. And our mission today is to explore a profound shift that is happening right now. We are officially moving away from AI as a passive chatbot, just waiting for your prompt.
Right, waiting for instructions.
Exactly. And we're entering an era where AI is an autonomous agent.
Yeah, and the shift here is, it's structural. I mean, these agents are now writing their own code. They're independently consolidating their memories by literally dreaming.
Dreaming, yeah.
Yeah, and fundamentally, they're breaking the digital infrastructure that we spent the last 2 decades building. It's essentially the tools building the tools now.
Okay, let's unpack this. Because we have to start with that staggering Anthropic metric about what they're calling recursive self-improvement. Because, it's one thing for an AI to write a quick Python script for a college student.
Sure.
But Anthropic is reporting that 80% of their new production code, and we're talking about the code running Claude itself, is now authored by Claude. The typical engineer over there is shipping like 8 times more code than before.
Yeah, and that 8x acceleration, it fundamentally alters the physics of software engineering. I mean, when humans write code, it's a very linear sequential process, right?
Right. You check out a branch, write your logic, run some tests, and push a commit.
Exactly. And the underlying architecture of platforms like GitHub, it was built to handle that specific human rhythm. But an AI agent, it just doesn't work linearly. It can spin up 50 parallel instances of itself and just simultaneously be writing, testing, and submitting concurrent pull requests across dozens of repositories.
Which perfectly explains why GitHub's infrastructure is just buckling under the pressure right now. I mean, their chief operating officer, Kyle Daigle, recently detailed how AI coding agents have driven a 1,400% growth in code shipped this year.
That number is just, it's hard to even process.
It really is. I mean, if we think about GitHub's API rate limits and continuous integration runners like a set of toll booths on a highway.
Yeah, like that.
Those booths were perfectly designed for a steady stream of Sunday drivers, right? Just humans cruising along. But suddenly, you have a massive swarm of autonomous Formula One race cars hitting the toll booths 24/7, and they're all demanding to be processed simultaneously.
And the API gateways simply freeze.
Oh.
They physically cannot parse the volume of concurrent requests. And we are seeing this evolution, from text generation to structural generation everywhere right now. Like Perplexity, for example.
Oh, right, the search as code thing.
Yes, Perplexity just introduced search as code, or SAC. Historically, a search engine is just a massive monolithic index. You type a query, it checks the index, it returns a link. But with SAC, Perplexity is giving AI models an SDK to directly configure and build tailored search pipelines on the fly.
Wait, so let me make sure I'm wrapping my head around the actual mechanism here. Instead of the AI just reading the search results, the AI is actively writing custom back-end routing logic in real time to go fetch exactly what you asked for.
That is the crucial distinction, yes. If you ask a really complex financial question, the agent uses the SDK to spin up a temporary pipeline. It scrapes specific SEC filings, runs a proprietary parsing algorithm, structures the data, and then it tears the pipeline down once you have your answer.
Wow.
Yeah, he's dynamically rearranging the digital pipes to suit the immediate task.
But, I mean, moving at that speed introduces a pretty terrifying variable, doesn't it? If these agents are writing code at 8 times the normal volume, and they're dynamically building back-end pipelines on the fly, the surface area for security flaws has to be expanding exponentially.
Well, absolutely.
So how do we even secure a digital infrastructure that is being so rapidly built by machines?
Well, that is the defining security crisis of this generation of models. We are seeing firsthand how capable these agents are at exploiting vulnerabilities, not just creating them.
Right.
Look at that recent experiment, the one where a developer built a deliberately vulnerable book review app. They gave various large language models a budget of $1,500 and a really simple goal, which was just to find the hidden flag in the user's private reviews.
Basically a literal bounty hunt for the AI.
Exactly.
But how does an LLM actually execute a hack like that? Is it just like brute forcing passwords over and over?
No, it's far more sophisticated than that. GPT 5.5, which succeeded 7 out of 10 times, by the way, brute force anything. It analyzed the app's architecture, identified the specific API route handling authorization, and deployed these chained prompt injections.
Chain prompt injections.
Yeah, it essentially tricked the back-end logic into bypassing its own security checks. And DeepSeek V4 Pro managed the exact same exploit 3 out of 10 times.
Okay, but what about Claude Sonnet 4.6? Because Anthropic usually prioritizes safety above basically everything else.
Well, Claude Sonnet 4.6 actually failed the bounty hunt.
Really?
Yeah, but the reason why is fascinating. It didn't fail because it lacked the intelligence to find the vulnerability. It failed because it constantly hit its maximum budget limit, or it just kept tripping over its own internal safety guardrails.
Oh, I see.
It spent all of its compute cycles endlessly debating whether exploiting the vulnerability violated its ethical training rather than just executing the hack.
Wow. Well, I mean, that overcaution makes sense given Anthropic's current enterprise push. They're really trying to position themselves as the ultimate automated security guard right now.
They definitely are.
They just released the Defending Code reference harness, which is an implementation for autonomous vulnerability discovery. And they've already scaled Project Glasswing to more than 150 organizations, including big names like Apple and CrowdStrike.
And the results of Glasswing really speak to the sheer volume of the problem here. Those partner organizations have already used the model to discover over 10,000 high or critical level security flaws in their systems.
10,000?
Yeah. But, as you scale these defensive agents, the models themselves become high-value targets.
Which perfectly brings us to the leak of Anthropic's new checkpoint model, the one codenamed Claude O'Shannon's V1P.
Right, the red team leak.
Yeah. They granted early access to independent red teams to aggressively stress test the model before doing a public launch. But they had to suddenly pause the whole program because one of the individuals involved was caught secretly reselling API access to the model through a Chinese proxy server.
Yeah, because the physical hardware and the proprietary weights powering these models are incredibly heavily guarded assets right now. And, just to impartially report the geopolitical context related to this, the U.S. Commerce Department actually recently issued guidance closing a major trade loophole.
Right.
Previously, advanced hardware, like NVIDIA's top-tier chips, they could occasionally reach Chinese companies through foreign subsidiaries. But the new export license requirements now strictly extend to any entity headquartered in China, regardless of where their subsidiary is physically located on the globe.
Which is a massive effort to just choke off the compute required to train these autonomous systems.
Exactly.
But I do want to push back on the software side of this security dynamic for a second.
Okay, go for it.
Because if we have AI agents writing code at an 8x scale, which inevitably introduces massive amounts of vulnerabilities, right? And then we deploy tools like Anthropic's reference harness to patch those bugs, aren't we just watching an automated immune system battle an automated virus? Like, where does the human engineer actually fit into this loop?
This raises an important question about how our very concept of software engineering must adapt. Because the human role is rapidly shifting from writing syntax to orchestrating testing environments.
Okay, how so?
Well, look at Cognition, the company behind the Devon AI software engineer. Their engineer, Ido Paisak, recently revealed that for every piece of code one agent writes, they're now running 10 to 20 Devons in parallel just to verify.
Wait, meaning they're setting up 20 separate CI/CD pipelines handled by 20 independent AI agents just to review a single pull request.
Correct. The verification process requires spinning up temporary development servers, running the logic through edge cases, and analyzing all the telemetry.
That's insane.
Humans physically cannot read code fast enough to verify the sheer volume being generated right now. So the human engineers are now designing the parameters of the test, while the agent swarm executes the actual review.
But security isn't just about fending off external hackers, or catching buggy code before it merges. The real headache for enterprise integration is internal.
Oh, for sure.
It's about an AI agent navigating the internal boundaries of a company, which requires it to remember who exactly it is talking to.
Yeah, the internal cybersecurity and governance landscape is where most enterprise agents are currently failing. And to be clear, They aren't failing due to a lack of reasoning capabilities. They are failing because of the permissions architecture.
Right. Like if you are a manager listening to this right now and you ask your company's AI to summarize the financial runway, the system needs to know your exact clearance level. If you're the CEO, you get the full deck. But if you are, say, a graphic designer, the system needs to block that request entirely. And Workday is attempting to solve this by using its core HR system of record as a hard governance layer for Google's Gemini.
And the mechanism there is so critical. When you prompt Gemini, the query doesn't just go straight to the language model. It first hits Workday's Identity Management API.
Ah, okay.
Workday checks your organizational chart, retrieves your specific employee security token, and then injects that token into the prompt behind the scenes. So Gemini is physically gated from retrieving any database vectors that do not match your exact security clearance.
So it fundamentally changes how the AI perceives the data itself. Centra CEO Ashwin Gopinath has a brilliant framing for this, actually. He argues that memory is purpose.
Yes, I love that concept.
He says memory isn't just a sidecar to intelligence. It is the foundational layer that dictates the very reality the AI reasons over. He uses the boulder problem to explain this, right?
Yeah, the boulder problem perfectly illustrates the danger of static memory. Because if you drop a giant boulder in the middle of a company's office, the artifact is physically identical for everyone.
Right, it's just a rock.
Exactly. Yeah. But if the AI assesses that boulder through the data permissions of the sales team, the boulder is an obstacle blocking the path to closing deals. But if it looks through the product team's permissions, suddenly it's a raw material for a new feature. And to the legal team, it's a massive liability risk.
So if you just treat AI memory like a static filing cabinet, you freeze the AI's understanding in the completely wrong frame of reference. The memory has to act more like a pair of prescription glasses.
That's a great way to put it.
Yeah, like when the AI puts on the sales glasses, those lenses actively filter the database vectors to show one reality, but swap them for the legal glasses, and the internal landscape completely alters.
But managing those dynamic, purpose-driven memories requires constant maintenance. The AI has to regularly update its understanding of the enterprise without, confusing the different user permissions. And this is exactly why we are seeing frontier models introducing literal dreaming phases.
Which sounds incredibly poetic, honestly, until you realize what ChatGPT rolling out Dreaming v3 actually entails.
Right? The engineering behind it is fascinating. A server farm sleeping is really just a period of off-peak compute where the model runs a process called distillation and replay.
Distillation and replay, okay.
Yeah, so during the day, the AI accumulates an enormous amount of short-term, in-context knowledge from user chats, right?
Yeah.
And this is stored in its KV cache. But maintaining a massive KV cache is incredibly expensive, and it degrades inference speed.
So at night, it has to move that data from its short-term memory into permanent storage.
Exactly. Using reinforcement learning, the model evaluates which facts and user preferences from the day were the most vital. It then subtly updates its base neural weights, which are the actual parameters of the model, to basically bake that knowledge in permanently.
Wow.
And once the weights are updated, it flushes the short-term cache. Google researchers actually just published a paper proposing this exact paradigm, generating synthetic curricula for the AI to self-improve overnight.
But, if that distillation process isn't perfectly partitioned by user permissions, you get catastrophic data leaks. A recent survey by Manzira looked at current agent harnesses and found 57 to 71% cross-user contamination rates.
Which is terrifying, meaning the model distills a highly confidential strategic plan discussed by the CEO during the day, bakes it into its foundational weights at night, and then accidentally hallucinates those details the very next morning when answering a benign question from an intern.
Basically, the prescription glasses get crossed during the dreaming phase.
Exactly.
Which is an absolute nightmare for corporate compliance. Now, whether you're running 20 parallel agents to verify code or spending overnight compute cycles distilling memories, all of these autonomous processes demand an absolute ocean of processing power.
Yeah.
And that compute requires terrifying amounts of capital. The economic reality check hitting the industry right now is severe.
Oh, it's brutal. We are witnessing unprecedented capital requirements just to keep the lights on. Alphabet is currently planning to raise $80 billion through stock sales, entirely earmarked just to fund the build-out of their AI compute infrastructure.
But while the tech giants are spending tens of billions on these server farms, the companies actually buying the AI are experiencing major sticker shock.
Oh, big time.
Anthropic recently submitted a confidential draft S-1 registration for a proposed IPO, but the underlying data shows growing corporate fatigue. Reports indicate that 40% of Anthropic's enterprise clients are currently seeing less than 10% cost savings from implementing AI.
Because the math simply isn't working out for the end user yet.
Yeah.
Think about it. If a company replaces a human coder with an AI agent but then has to pay API inference costs for 20 parallel testing agents just to verify the code, plus the overnight compute for memory distillation,
Right.
their operational costs just completely explode. And if businesses aren't seeing massive efficiency gains, they will inevitably refuse to renew those really expensive enterprise contracts. This is why Microsoft is attempting to pivot the market's focus by introducing a new metric on their release cards called intelligence per dollar.
Which is essentially measuring the average token usage required to complete a specific task against the overall cost of the model.
Yeah, it forces the market to stop focusing solely on brute force benchmark scores and start actually competing on operational efficiency. It's an attempt to align the price of the AI with tangible business outcomes, like completed customer support tickets, rather than just theoretical capabilities.
Here's where it gets really interesting, because while closed model giants like OpenAI and Anthropic are scrambling to justify their enterprise price tags to these fatigued clients, the open source community is completely upending the cost structure. Look at the open weights model NVIDIA just dropped, Nematron 3 Ultra.
Oh yeah, Nematron 3 Ultra is a game changer. It is a 550 billion parameter model that you can just download and run on your own infrastructure. It scored a 48 on the Artificial Analysis Intelligence Index.
Which is wild.
Yeah, it left the previous open source leader, Gemma 4, completely in the dust.
And Minimax just released the M3 model, which combines frontier-level coding capabilities, native multimodality, and this massive 1 million token context window. And it's all completely open weights.
Right.
If these open models are offering specialized architectures that companies can just run locally, drastically reducing per token inference costs compared to, say, hitting Anthropic's API for every single line of code, how do the closed labs survive the economic squeeze?
Well, the consensus forming among researchers right now is that the closed labs are incredibly vulnerable because the open and closed ecosystems are riding two entirely different exponential curves. Currently, enterprise clients feel that open models lack the final polish required for highly complex edge case reasoning. But the open source community operates via decentralized innovation. It is a global network of engineers actively optimizing inference efficiency at the hardware level.
Right, compared to a centralized lab burning billions on brute force training.
Exactly. The sheer volume of localized experimentation is expected to eventually outpace centralized capital, making the total market value of the open economy much, much larger.
It's the ultimate David and Goliath dynamic, except David is crowdsourced and highly optimized.
Perfectly said.
So let's take a breath and synthesize the journey we've taken today. We began by establishing how AI is fundamentally changing from a passive tool to an autonomous agent, writing 80% of Anthropic's code and literally breaking GitHub's API architecture through sheer concurrent volume.
Yep.
We explored how agents are deploying chained prompt injections to hack vulnerabilities, forcing companies to deploy swarms of AI testers just to keep up.
And we examined the internal mind of the AI, how systems like Workday are using API tokens to dynamically filter an agent's reality, and how these models are actively dreaming at night, using reinforcement learning to permanently bake short-term context into their neural weights.
And finally, we confronted the economic breaking point, the massive $80 billion infrastructure bills colliding with enterprise sticker shock, all while highly efficient open weights models threaten to undercut the entire closed lab business model. This brings it directly back to you listening to this deep dive. How are you evaluating AI for your team right now?
It's a crucial question.
Are you just chasing the most expensive, highest scoring model on the leaderboard? Or are you looking closely at the specific permissions architecture your company requires and the actual intelligence per dollar you are getting? So what does this all mean?
What's fascinating here is that raw intelligence is no longer the bottleneck. Intelligence is rapidly becoming commoditized and incredibly cheap, especially via these localized open weights models.
Right.
The new defining competitive advantage is architectural design. It is the human ability to define the precise testing parameters, to strictly govern the identity management APIs, and to carefully orchestrate the reality the AI is permitted to see. The human is no longer the author of the code, The human is the architect of the environment.
The architect of the environment. I really love that framing. But before we wrap up, I want to leave you with one final, wildly provocative thought pulled directly from our sources today. Because everything we've discussed today, the parallel agents, the dynamic permissions, the overnight memory distillation, it has all been confined to servers and browser tabs. But the next frontier is breaking out of the digital box, physical AI.
Right. Taking the agentic logic and embedding it into the physical world.
NVIDIA just launched Cosmos 3, an open physical AI foundation model designed entirely for robotics. They've unveiled the N1X laptop chip, featuring an RTX 5070 equivalent GPU specifically built to run heavy AI models locally on edge devices.
Which is huge.
And at the exact same time, OpenAI Robotics is aggressively hiring hardware and systems engineers to manufacture actual physical robots. So I leave you with this to mull over. We've spent this entire time talking about digital agents operating in the cloud. What happens when these recursive, self-improving, dreaming autonomous systems finally get downloaded into a physical chassis standing right in your living room or your warehouse?
Yeah, that changes everything.
When the agent doesn't just rewrite the software, but physically navigates the hardware. It is a wild frontier out there. Thanks for joining us on this deep dive, and we'll catch you next time.
Spoken Tech for your ears.